one heavy light block because related to the following choice, the external leg is light and the internal loop is heavy. The opposite option does not exist just because the expansion coefficient of the torus blocks already first coefficient has a pole in the exchange dimension. Okay, and in particular it means that there is now this so-called vacuum approximation which was instrumental in calculating the entanglement entropy on a sphere, because we cannot set this loop to zero, contrary to vacuum blocks on a sphere. Another semi-classical block is the classical conformal block itself, and this is the case when two operators are heavy, so the respective conformal dimensions grow linearly with the central charge. And in particular, it's interesting to consider the case when the loop or the third-pole diagram is much more heavier than the external leg. In this way, we obtain the linearized classical conformal block, and some later will show that it's this linearized classical conformal block which can be realized holographically in the formal ADS. So our point here is that all these four types of semi-classical torus blocks are not quite independent, and instead they are linked to each other by a chain of connections. So now let us start from considering global torus block, and we know that Virasoro algebra of a CFT living on arbitrary Riemannian surface has a finite dimensional subalgebra SL2. So the global block by definition is just the block associated to this SL2. Okay, we see that it does not depend on the central charge, and in fact the global block is just a d-dimensional conformal block restricted to 2 dimensions. Okay, in this case the general expression for the quantum block drastically simplifies, and the corresponding expansion coefficient are given by these matrix elements, where instead of all Virasoro generators we have only L-1, L+1 and L0, which is just the commutator of this L+-1. So these three generators form SL2 subalgebra, and the expansion coefficient can be explicitly calculated and shown that they can be packed into the hypergeometric function of this form multiplied by this power law prefactor. And as a consistency check we can consider the limiting case when the dimension of the external leg tends to 0, and in this case this global block is just given by this expression, and we see that this is the character of SL2 algebra, and the form of this function indicates that there is just one state on each level of the corresponding SL2 module. Now, the most important thing about the global block is that it satisfies the second-order differential equation given here, and we would like to consider the regime where conformal dimensions tend to infinity in a coherent manner, meaning that we introduce some large parameter kappa, and the sigma and sigma tilde are just rescaled conformal dimensions. So from the general theory of differential equations, we know that in this case the solution exponentiates like this, where function g is given formally by this integral, and actually this is very important result for us, because some later we will show that this exponentiated global block is directly related to the linearized classical block. Okay, another comment is that on a sphere we already met this kind of second-order differential equations, which are just the so-called Casimir channel equations, and actually the appearance of this second-order equation is not occasional. Okay. Now we consider another semi-classical block with light operators, and it is the light torus block, and in general it can be defined as a leading asymptotic or the quantum Virasoro block when the central charge tends to infinity. And in this regime, by the way, we just had this power law prefactor, and since it diverges in this limit, we just moved it on the left-hand side to single out the finite part of the conformal block. So this leading asymptotic is the light block, and the most important thing about light block and global block is that they are related to each other by the relation of this kind, where function phi is the standard Euler function, which defines a particular Virasoro character. And having this prefactor 1 minus q says that global and light block are different by this prefactor, which is truncated Virasoro character. Okay, a few comments are in order. So first of all, this light block in one-point case is the leading asymptotic for the so-called C-recursive relations which define one-point quantum torus blocks. And another important observation that this factorization property actually is general for any Riemannian surfaces and for blocks with arbitrary number of operator insertions. So in the sphere case, global block and light block are equivalent, equal to each other, and following results of these offers, we now know that the sphere case is an exception, but in general, a light block and global block are related by this relation. Okay, now we would like to use the symmetry argument and show that all the semi-classical blocks are related to particular contractions of the Virasoro algebra. And as I have already noted, the conformal blocks are model independent, they are completely fixed by symmetry algebra, and it means precisely that any semi-classical blocks that follow from original quantum block should be somehow related to operations done with the symmetry algebra. And indeed, this is the case, and to this end we consider, first of all, Virasoro algebra, which is given by these standard commutation relations, and as we consider also primary operators, here we give how the primary operators transform under Virasoro transformations. So now let me remind you what the Inonu-Wigner contraction is. So this is a kind of limiting operation if you have an algebra, and this algebra is parameterized by some small parameter, then you can send this parameter to 0 to obtain another algebra. And a canonical example here is how Poincare algebra is related to ADS algebra, or Galilean algebra is related to Poincare algebra. So in the first case we have cosmological constants, so we can rescale generators of ADS algebra with help this cosmological constant and then send it to 0 to obtain Poincare algebra. In the case of Galilean algebra, this is just the speed of light, and sending the inverse speed of light to 0, we obtain Galilean algebra from Poincare algebra. So in our case, Virasoro algebra is parameterized by the central charge. So sending to 0 the inverse central charge, we can study various contractions. Okay, consider now general rescaled Virasoro generators, which are given by this expression where gamma is some function of integer parameter m. Then we distinguish between two main choices when the Virasoro generators are rescaled in this way, it means precisely that the finite dimensional part of Virasoro generators remain intact, while other Virasoro operators are rescaled into different ways. So, since we also consider primary operators, we can show that this transformation law reduces to this general relation, saying that the primary field is still SL2 primary field, but with respect to these higher order Virasoro generators, it's just a singlet. Okay, and doing these constructions, we observe that in the first case, the Virasoro algebra decomposes in two parts. The first part is SL2 subalgebra, and the other part is infinite dimensional abelian factor, and this is expressed by these two lines, and we see that the whole contracted Virasoro algebra is just a semi-direct sum of SL2 and this infinite dimensional abelian factor. In the second case, this contracted algebra now contains, instead of abelian factor, the Heisenberg algebra, which is given by this H with the respective commutation relations. So for these two contractions, we have two contracted algebras which are both semi-direct products of finite dimensional SL2 and infinite dimensional factor, which is either abelian algebra or Heisenberg algebra. So our main proposition is that light and global blocks are just associated blocks which can be calculated using these two contracted algebra. In the first case, we obtain a global torus block, and in the second case, we find the light torus block. In particular, it's clear why global block is related to singling out SL2 subalgebra. This is because we consider irreducible representations, and it means precisely that this infinite dimensional abelian factor is trivially realized. It's not the case for the Heisenberg algebra, and calculating the associated block gives rise to that prefactor related to Euler function. Now we consider one more semi-classical block, which is the heavy light torus block, and as I explained earlier, one of dimensions, external dimension, is light, while the loop is heavy. So the corresponding heavy light torus block can be explicitly calculated up to high enough order in the modular parameter, and it's given by this inverse Euler function. So it's also, thank you very much, it's also not independent, and we can show that the heavy light block is just a limiting case of the light block. So considering the light block and sending the internal dimension to infinity, we reproduce this heavy light block. So also we observe that since the heavy light block does not depend on conformal dimensions at all, it's just a zero-point block or Virasoro character. And this situation is quite similar to what happens on a sphere, where these relations were observed for 4-point blocks and 5-point blocks. Okay, the heavy light block also admits this Virasoro contracted algebra interpretation. In this case, we rescale all Virasoro generators, including the SL2 part, and show that the contracted Virasoro algebra commutation relations in this case take this form, which up to linear transformation, changing the basis, we can cast this commutation relation into the standard Heisenberg algebra commutation relation form. So calculating associated conformal block, we arrive exactly at this expression. So up to now we considered 3 different semi-classical blocks, and they are all related to particular Virasoro algebra contractions. Finally, we consider the so-called torus conformal block, classical torus conformal block, and in this case all operators are heavy. So the respective dimensions grow linearly with the central charge, and we can substitute these dimensions into the conformal block and expand the resulting function around the infinite value of the central charge. So in this way we obtain some Laurent series, which has a principal part, which has a regular part, and the respective coefficients are just some formal power series in the modular parameter with next level expansion coefficient being some rational functions of classical conformal dimensions. And the most important thing about the classical block is that at large C the principal part of this expansion goes to zero. Less obvious is that the regular part exponentiates, and it follows that the one-point torus block is asymptotically equivalent to this expression at large C. And this function, which is called classical conformal block, can be explicitly calculated up to high enough order. So the first coefficient is given here. In particular, we see that it has a pole with respect to exchange dimension. Okay, so we see that we have four types of semi-classical conformal blocks, and three first blocks, which are global light and heavy light blocks, are just limiting cases when we send the central charge to infinity, while the classical block is the large C asymptotic of the original quantum block. Unfortunately, there is no any interpretation in terms of contracted Virasoro algebra, but I believe that there should be kind of deformation theory with respect to small inverse charge, starting from some contracted Virasoro algebra, which takes account of all these corrections in the central charge. So this is not done yet, and actually I believe that up to now we consider classical blocks as a kind of asymptotic expansion around infinite central charge, but there should be some symmetry algebra, Virasoro algebra formulation in the spirit of these contracted Virasoro algebras. Now we consider the linearized conformal block, and to this end we introduce this whole lightness parameter, which is just the ratio of two conformal dimensions, and then changing from the original classical conformal dimensions to delta, the lightness parameter, and the external conformal dimension, we can reorganize the whole conformal block function in terms of the double series expansion in delta and epsilon tilde, and find this expression which says that we keep terms at most linear in the external conformal dimension. So instead of the power series in the modular parameter, for the linearized conformal block we have these two terms, where the second term is given by power series in the lightness parameter, while the expansion coefficient are just some rational function of the modular parameter. So this is the point where we should recall about the global block, and we conjecture that exponentiated global block is equal to the exponentiated quantum block, that is, it is equal to the linearized classical block. So recalling that function which appeared for the global block, we see that modular this logarithmic contribution, these two functions just coincide. And the most important thing about this conjecture is that for the global block we know some formal integral representation, which is given here. So we conjecture that the linearized conformal block on a torus in one-point case is given by this integral. And finally, let me comment that this relation is analogous to what happens on a sphere case and for 4-point blocks and 5-point blocks. Now we realized linearized conformal blocks in terms of particular geodesic networks stretched in a three-dimensional bulk, and we see that we can show this explicitly, that taking this tedpole diagram of one-point conformal block on a torus, we arrive at particular tedpole geodesic